Nothing on Earth decides when the ice comes. Not the oceans, not the winds, not anything happening on the surface of this planet. And yet the ice does come. Sheets of it more than 2 miles thick that have buried the ground your city sits on, melted away and buried it again, dozens of times, in a rhythm as steady as a heartbeat. For the longest time, no one could say what was keeping that rhythm, but here is what almost nobody has ever told. The ice ages are not really about temperature at all. They are about geometry, the slow bending of Earth's orbit, and the Earth cannot bend its own orbit. Something else is doing it. Something enormous and patient and hundreds of millions of miles away. 2 planets you will never visit have had their hands on the fate of the ice this entire time, and almost no one alive knows their names are even involved. Get comfortable, hit subscribe if you're new here, because by the end of this, the mild sky over your head will never feel quite like your own again, and you will know exactly whose slow hands have been keeping time above you the whole while. Now, let's slowly ease into this. Part 1. The beat nobody marks. Earth's climate keeps time. That is the first thing to sit with tonight, and it is stranger than it sounds. When you stretch the record of this planet's temperature across hundreds of thousands of years, you do not find a smooth line, and you do not find random noise either. You find a rhythm. Cold, then warm, then cold again. Ice creeping south across whole continents, then crawling back north, over and over, with a regularity you would expect from a clock rather than a planet. Nobody sends out a warning when this happens. There is no headline, no flash in the sky, no single night you could circle on a calendar. The change is so slow that a person could live an entire life inside one of its quiet stretches and never feel the floor move beneath them. And yet the movement is there, patient and enormous, and it has been running for millions of years, long before there was anyone here to notice it at all. Start with a fact that should not be true, but is. The freezing and the thawing of this world are not accidents. Ice sheets more than 3 kilometers thick, almost 2 miles of solid ice, have buried the ground your cities now sit on. They melted away, they came back and buried it again. And the timing of all that burial and retreat is not scattered or arbitrary. Something is keeping the beat. For a very long time, nobody could say what. Consider how odd that is. We tend to imagine climate as a kind of weather that never ends, something driven by the sun overhead, by oceans and winds and the accidents of a given century. We imagine it drifting, wandering, responding to whatever happens to be going on down here on the surface. But when you pull far enough back, the drift disappears and the pattern takes over. The cold ages return on a schedule, the warm ages return on a schedule, and a schedule by definition is being set by something. The evidence for the cold ages themselves was never really in doubt. It is written into the rock, into the scratched and gouged landscapes that ancient glaciers left behind as they ground their way across the land. You can stand on stone that still carries the grooves where a moving wall of ice dragged boulders across it tens of thousands of years ago. The ice was real. The question was never whether it happened. The question was why, and the why was a wall. Think about the size of what has to be explained. Something reached out and froze half a planet on a schedule. Then it warmed that half back up. Then it froze it again, and warmed it again. Not once or twice, but again and again across a span of time so long that the whole of human history barely registers inside it. Whatever keeps this rhythm is not gentle in its effects, even if it is gentle in its methods. It has repeatedly rearranged the surface of an entire world. Here is the part that should quietly unsettle you. If the climate keeps a beat, then the climate is not really in charge of itself. A thing that keeps time is following something. A drummer keeps time, but a drummer is reading a rhythm that exists apart from the drum. And if the ice ages follow a rhythm, then the rhythm has an author, and the author is not the ice, and it is not the ocean, and it may not even be anything on this planet at all. For most of human history, that thought would have been unthinkable, because we had no way to see it. You cannot notice 100,000-year rhythm in a single human lifetime. You cannot feel it in a season, or a decade, or the memory of your grandparents. It is a pattern that only becomes visible when you can read time the way a geologist reads it, in layers and cores and the slow accumulation of evidence pressed into stone and ice. And when we finally learn to read time that way, The pattern was waiting there, exactly as regular as a heartbeat. So let me tell you where this is going slowly, because there is no rush tonight. There is a machine that has been deciding the fate of the ice. It hides in plain sight, out at the edge of the solar system, and it has been running the whole time, indifferent to us, older than us, and it explains why the planet you are standing on has never truly been in control of its own climate. To find that machine, we have to follow the rhythm back to its source, and the first step is to look more closely at the beat itself, because the beat is where a lone man with a pencil first heard something that nobody believed he could possibly hear. Part 2. The Rhythm in the Rock. The ice did not come once. That is one of the first things that breaks your sense of how the world works. We tend to picture a single ice age, one great winter in the far past, a frozen chapter that ended and gave way to the world we know. But that is not what the rocks say. Over the last few million years, the Earth has swung into glaciation, and back out of it dozens of times. The ice has come and gone the way a tide comes and goes, except that this tide is measured in tens of thousands of years instead of hours. Each time it advanced, it did something almost impossible to picture. Sheets of ice thick enough to crush the landscape spread down over the northern continents. So much of the world's water was locked up in that ice that the sea itself dropped. During the coldest depths, global sea level fell by more than 100 meters, over 300 feet, and the retreating oceans exposed land bridges where there had been open water. Early humans walked across some of those bridges to reach new parts of the planet, following the shape of a world that the ice had temporarily redrawn. Then the rhythm shifted. The northern summers warmed, the ice pulled back, and the seas rose again to drown the very bridges that people had crossed. The coastlines, you know, the islands, the shallow seas, the places where the first settlements took hold, were carved in part by this slow pulse of freezing and melting. The map itself is a record of the beat. We live on the geography that the rhythm left behind the last time it exhaled. Now hold on to that number for a moment, because it matters. More than 100 meters of sea level, appearing and disappearing, again and again. That is not a minor wobble in the weather. That is the ocean of an entire planet rising and falling on a schedule. Whatever keeps this rhythm is moving quantities of water and ice that dwarf anything human beings have ever built or destroyed, and it does it so slowly that no one alive during any single swing would ever see it as an event. They would only ever see a coastline that seemed, within their lifetime, to be standing still. Let me put you inside one of those cold ages, because the numbers stay abstract until you stand in them. Go back about 20,000 years, to the last time the ice was near its worst. If you lived anywhere across the northern half of the world, imagine the ground beneath your feet buried under a wall of ice taller than the tallest building in your city. Not a glacier you would travel to see, a frozen ceiling pressing down on the exact land where your home now stands, in some places more than 3 kilometers thick, grinding slowly southward and scraping the ground flat as it moved. The air in that world was bone dry and brutally cold. The sea had pulled back so far that beaches you know today would have sat far inland. The shoreline retreated over the horizon and out of sight. Whole forests were simply gone, replaced by frozen plains that ran for hundreds of miles, and none of it, not 1 degree of that cold, was triggered by anything happening on the Earth's surface. The thing that decided your patch of the planet would freeze was the angle of sunlight falling on the far north. Nothing more dramatic than that. An angle. That is the detail that turns this from a story about ice into a story about geometry. The ice ages are not really about the planet getting colder in the way you might imagine, some furnace being turned down somewhere. They're about whether the far north receives enough summer sunlight to melt the snow that fell the previous winter. When the summers are warm enough, the snow melts, and the world stays open. When the summers are just slightly too cool, the snow survives. It lingers through the season. It piles up, year after year, century after century, and it slowly grows into an ice age. Sit with how small the trigger is compared to the result. We're not talking about the sun going out, or some catastrophe hitting the planet. We're talking about a modest change in how much sunlight reaches the northern latitudes in summer. That small change, sustained and repeated, is enough to bury continents. It is the difference between snow that melts by August and snow that does not, multiplied across thousands of years, until the unmelted snow becomes a sheet of ice 2 miles thick. And this raises the question that should have been growing in the back of your mind since we started. If the ice depends on summer sunlight in the north, Then what changes that sunlight on such a regular schedule? The sun is steady. It does not lean toward the northern hemisphere on a 100,000-year timer of its own accord. Something else has to be moving. Something has to be tilting the sunlight, stretching it, rationing it out to the far north in a rhythm precise enough to leave its signature in stone. For centuries, nobody had the faintest idea what that something could be. And then a man sat down with a pencil and a stack of paper and decided to calculate the geometry of the entire problem by hand. Part 3. The Man with the Pencil. The answer came from someone working almost entirely alone. His name was Milutin Milankovic, a Serbian engineer and mathematician born in 1879, and he set himself a task so tedious that most people would have called it impossible. He wanted to work out, century by century, how the shape of Earth's orbit and the tilt of its axis slowly change over tens of thousands of years, and how those changes alter the sunlight falling on every latitude of the planet in every season. He wanted to calculate the sunlight of the distant past, and he wanted to do it by hand. There is something worth pausing on in that phrase, by hand. Milankovic had no computer. He had no calculator in any sense you would recognize. He had paper and a pencil and the mathematics of how a planet moves, and a stubbornness that is genuinely difficult to imagine. The calculations ran for page after page, year after year of arithmetic, tracing the slow drift of Earth's motion across the ages and converting that drift into numbers for how much sunlight reached the northern latitudes at different moments in the past. Picture the room: a lamp, a desk, and a man bent over columns of figures that stretch down the page and onto the next and the next. Outside, the ordinary world goes on, but in here there is only the scratch of a pencil and the quiet turning of pages. He's not calculating for a day or a week. He's calculating the sunlight of 100,000 years ago, and then the sunlight of 90,000 years ago, and then 80,000, patiently, one slice of ancient time after another. Part of this work he does as a prisoner. When the First World War breaks out, he is captured and interned, and rather than let the years empty out, he arranges to continue his calculations in a library, filling notebook after notebook while the war grinds on outside the walls. He's chasing a single idea through all of it, an idea most of his contemporaries find far too tidy to be true. The idea is that the ice ages are not weather at all. The idea is that the ice ages are written in the geometry of how the Earth moves around the sun, and that if he can only do enough arithmetic, he will be able to read them. He keeps writing. The columns keep growing. And slowly, out of nothing but patience and numbers, a pattern begins to appear. He was right. That is the remarkable thing. Decades later, when the tools existed to test what he had done, the rhythm he had calculated with a pencil turned out to match the rhythm buried in the Earth. But to understand what he found, and why it should genuinely unsettle you, you have to understand the thing he understood first, which is that the Earth does not move in a fixed, reliable, unchanging way. We are taught to think of the planet's motion as a settled fact, a stable circle around a stable sun. It is not. 3 separate things about Earth's motion drift slowly over long cycles, and Milankovic worked out all 3. The first is the shape of the orbit itself. Earth's path around the sun is not a perfect circle, and it does not even stay the same in perfect shape. It slowly stretches out into a more oval path, and then relaxes back toward a rounder one, over and over, on a cycle that runs roughly 100,000 years long. That slow breathing of the orbit, from rounder to more stretched and back, changes how the planet's distance from the sun varies across the year. The second is the tilt of the axis. The Earth spins on an axis that is tipped over relative to its orbit, and that tilt is the reason we have seasons at all. But the angle of the tilt is not constant. It nods up and down, rocking between a little over 22 degrees and about 24.5 degrees, across a cycle of roughly 41,000 years. When the tilt is greater, the seasons are stronger, and the summers at high latitudes are warmer. When the tilt is smaller, the seasons are milder, and the northern summers cool. The third is the wobble. The axis does not just nod, it also traces a slow circle, like a spinning top that has begun to lose its balance and sweeps its axis around in a cone. This wobble, called precession, takes somewhere around 23,000 years to complete one full turn. It changes which season happens when the Earth is closest to the sun, so that over thousands of years the timing of the seasons slides against the timing of Earth's distance from the sun. Now stack those 3 rhythms on top of each other. one that stretches the orbit over about 100,000 years, one that rocks the tilt over about 41,000 years, one that sweeps the wobble around over about 23,000 years. Each one is slow, each one is gentle, but when you lay them over one another, they combine into a single, complicated pattern, and that pattern controls exactly how much summer sunlight reaches the far north at any given moment in history. When the three cycles line up in the wrong way, the northern summers stop being warm enough to melt the winter's snow. The snow survives, it accumulates, and an ice age begins. That is what Milankovitch heard in his columns of arithmetic. He heard the three rhythms of Earth's motion combining into the rhythm of the ice. He had in effect reconstructed the heartbeat of the ice ages from nothing but geometry, decades before anyone had the means to confirm that the heartbeat was really there. And once you understand that the ice is set by these three slow motions, a door opens that is very hard to close again, because you are forced to ask a new question. If the ice depends on the shape of the orbit and the tilt and the wobble, then the ice is not about temperature in the way we thought at all. It is about geometry, and geometry, unlike weather, has to be moved by something. Part 4. It was never about temperature. Let this reframing settle all the way in, because it changes the whole story. When you hear the words Ice Age, your mind reaches for the idea of cold, as though the planet simply lost heat somehow, as though a thermostat somewhere was turned down. But that is not the mechanism. The mechanism is geometry. The ice comes and goes depending on how the Earth is tilted and where it sits in its slowly stretching orbit, because those things decide whether the summers in the far north are warm enough to undo the winters. Follow the logic slowly, because it runs against instinct. Snow falls in the north every winter, ice age or not. In an ordinary world, the summer arrives and melts that snow away, and the land is open again by autumn. The whole question of whether an ice age begins comes down to a single, quiet contest each year. Does the summer melt all of last winter's snow, or does some of it survive? If it all melts, nothing accumulates, and the world stays warm. If even a little survives each year, it stacks up, and over thousands of years the stack becomes a continent of ice. So the trigger for an ice age is not a colder winter. Colder winters, oddly, do not matter very much, because winters in the north are already cold enough to make snow regardless. The trigger is a cooler summer. It is the summer that fails to melt the snow. And what controls the warmth of a northern summer, over the long run, is not the weather but the geometry, the combination of tilt and orbital shape and wobble, that decides how much sunlight the high latitudes receive during those crucial summer months. Consider what the tilt does first, because it is the most intuitive of the three. The tilt of Earth's axis is what gives us seasons, leaning the northern hemisphere toward the sun in June and away from it in December. When that tilt is at the larger end of its range, close to 24.5 degrees, the lean is more extreme, and the northern summers get a stronger dose of sunlight. Strong summers melt snow. When the tilt relaxes toward 22 degrees, the lean is gentler, the summers weaken, and snow has a better chance of surviving. All of this plays out over the 41,000-year cycle of the tilt, slowly strengthening and weakening the seasons like a hand raising and lowering a dimmer switch on the northern summer. Now add the shape of the orbit. When Earth's path is more stretched and oval, the planet's distance from the sun varies more across the year, and the timing of that variation starts to matter enormously. And here the wobble enters, because the wobble decides whether the northern summer happens when the Earth is near the sun or far from it. Combine a stretched orbit with a wobble that puts northern summer at the far point of that orbit, and you get northern summers that are cooler than usual because the hemisphere is tilted toward a sun that is, at that moment, a little farther away. That is the recipe for snow that survives. None of these three effects on its own is dramatic. The changes in sunlight they produce are real but modest. What makes them powerful is that they stack and that they persist. A single cool summer means nothing. But a long run of slightly cool summers, sustained across thousands of years while all three cycles happen to conspire in the same direction, is enough to let snow build into ice and ice build into sheets 2 miles thick. The ice ages are the sum of many small patient nudges pointing the same way for a very long time. This is why the whole thing behaves like a clock rather than like weather. Weather is chaotic and short. It changes by the hour, by the day, driven by 1,000 tangled causes, but geometry is orderly. The tilt of an axis and the shape of an orbit do not lurch around unpredictably. They change smoothly, on fixed cycles, as reliable as the gears of a machine. And because the ice depends on the geometry and not on the weather, the ice inherits the orderliness of the geometry. It comes and goes on a schedule because the geometry that drives it runs on a schedule. Once you see it this way, the earlier mystery sharpens into something much more specific and much more strange. The question is no longer why does the planet get cold? The question is what moves the geometry, because the geometry is the thing that has to change to bring the ice. The tilt has to nod, the orbit has to stretch, the axis has to wobble, and a planet cannot do those things to itself. A spinning world does not spontaneously stretch its own orbit or rock its own tilt on a 100,000-year timer for no reason. Something has to be reaching out and moving it. That is the thought that should be quietly bothering you now, the same thought that bothered the scientist who followed Milankovitch. He had shown that the ice follows the geometry, but he had, in a sense, only pushed the mystery back one step. If the ice is set by the shape of Earth's orbit and the angle of its tilt, then what stretches the orbit? What tugs the tilt? What sets the wobble sweeping around? The Earth cannot be the author of its own motion, and when you finally chase that question all the way out, past the moon, past the inner planets, out toward the cold and the dark at the edge of the solar system, you find that the hands moving the geometry belong to two objects so large that the word we use for them has almost stopped meaning anything. You find the giants. Part 5. What moves the geometry? The planet cannot do it to itself. That is the sentence the whole story has been building toward, and it is worth saying plainly. Earth cannot stretch its own orbit. It cannot reach out and rock its own tilt. A body moving through space follows the paths that other forces set for it, and the shape of Earth's orbit, that slow stretch from nearly circular to slightly oval and back again, is not something the Earth is doing. It is something being done to the Earth, and once you accept that, you are forced to look outward, away from the planet entirely, to find the hands that are doing it. The Sun holds the Earth in its orbit, of course. The Sun's gravity is the leash that keeps us circling at all, but the Sun, on its own, would keep the Earth on a steady, unchanging path. A single planet orbiting a single star traces the same ellipse forever, without stretching or relaxing. The changes in the shape of Earth's orbit, the very changes that pace the ice ages, do not come from the Sun. They come from the other planets, tugging on the Earth from the side as they pass, adding their own small pulls to the great pull of the Sun. This is the piece that most people never learn, and it is the quiet center of the whole story. The planets do not travel in perfect isolation, each one minding its own orbit as though the others were not there. They feel each other. Every planet in the solar system is pulling gently on every other planet, all the time, across enormous distances. Most of the time these pulls are far too small to notice from one year to the next. But across thousands and tens of thousands of years, the pulls accumulate, and they slowly bend the shapes of the orbits, including ours. The stretch and relaxation of Earth's orbit is the sum of all those small tugs from all the other worlds, added up across ages. And the tugs are not equal, because the planets are not equal. Gravity depends on mass, and the mass of the planets is spread wildly unevenly across the solar system. A small light planet tugs weakly. A large, heavy planet tugs hard. So when you go looking for what actually reshapes Earth's orbit, you are really asking a simpler question. Which planets are heavy enough to matter? Which ones have enough mass to reach across hundreds of millions of kilometers and leave a mark on the path of a distant world? And the answer, overwhelmingly, comes down to the two largest planets in the solar system, the two giants that dwarf everything else combined. It comes down to Jupiter and Saturn. Let that reframe the night sky for a moment. When you look up and see Jupiter, that steady bright point that does not twinkle the way the stars do, you are not looking at a decoration. You're looking at one of the two hands that shapes the climate of your planet across geological time. The same is true of Saturn, fainter and farther, but no less involved. These are not distant curiosities with nothing to do with life on Earth. Their gravity is part of the machinery that decides whether the North freezes. And they have been doing it the entire time, for as long as there has been an Earth to pull on. There is something almost vertiginous about this once it lands. We spend our lives thinking of the planets as separate places, each one its own world, connected to us only by the thin thread of a telescope or a spacecraft. But gravity does not respect that separation. Gravity ties every mass in the solar system to every other mass, invisibly, permanently, with a grip that never lets go. Jupiter is pulling on you right now. So is Saturn. The pulls are unimaginably faint at the scale of your body, far too small for you to ever feel. But at the scale of a planet's orbit, sustained across 100,000 years, those same faint pulls are enough to stretch the path of the Earth and, through that stretch, to help decide the fate of the ice. Understand what this means for the question we started with. The rhythm of the ice ages, the beat that Milankovitch heard in his columns of arithmetic, is not really a rhythm of the Earth. It is a rhythm imposed on the Earth from outside, by the slow circling of the giant planets and the way their gravity works on our orbit over time. The clock that keeps the ice ages is not on this planet. Its gears are hundreds of millions of kilometers away, turning in the cold and the dark, and their turning reaches all the way here. This is why the planet you're standing on has never really been in control of its own climate. The fundamental driver of the ice, the shape of Earth's orbit, is set by forces the Earth has no say in. We did not choose the pull of Jupiter. We cannot alter the orbit of Saturn. These are the boundary conditions of living on this particular world, in this particular solar system, and they were fixed long before we arrived and will remain fixed long after we're gone. The ice comes when the giants and the geometry say it comes, and there is nothing on Earth that votes in that decision. To feel the full weight of that, though, you have to understand just how large these two hands really are. The word giant gets used so casually that it has almost lost its force. We call all sorts of things giant, but Jupiter and Saturn are giant in a way that breaks the ordinary meaning of the word, and until you make their size real, until you actually try to hold their scale in your mind, you cannot really feel what it means that they are the ones reshaping our orbit. So let me try to make the larger of the two real for you, because Jupiter is not merely big. Jupiter is so far beyond big that it changes what you think a planet can be. Part 6. The Heavy Hand. Jupiter is more massive than every other planet in the solar system combined, more than twice over. Sit with that sentence for a moment, because it is easy to read past and very hard to actually picture. Take every other planet, every rocky world and every gas world, Mercury and Venus and Earth and Mars, Saturn and Uranus and Neptune, all of them, and pour them onto one side of an enormous scale. Then put Jupiter on the other side. Jupiter still wins, easily. It outweighs all of its siblings put together with mass to spare. It is not the biggest planet by a comfortable margin. It is the biggest planet by a margin that makes the others look like rounding errors. Try it another way, by volume, because volume is a little easier to hold in the mind than mass. More than 1,300 Earths could fit inside Jupiter. 1,300 of our entire planet poured into one world. If the Earth were a marble, Jupiter would be a ball you could not wrap your arms around. Everything you have ever known, every ocean and mountain and city and person who has ever lived, all of it happened on a body that Jupiter could swallow more than 1,000 times over without noticing. When something is this large, it does not simply sit in its own lane in the solar system. Its gravity reaches inward across the whole system, and it never stops reaching. That reach is the thing to hold on to. Gravity, unlike almost everything else, does not switch off with distance. It weakens, yes, spreading thinner the farther you go, but it never becomes nothing. A mass as enormous as Jupiter throws its gravitational influence across hundreds of millions of kilometers, and that influence lands, faintly but constantly, on every other world, including ours. Jupiter has been pulling on the Earth for as long as both have existed. 4.5 billion years of unbroken tugging, never pausing, never tiring, a steady hand that has never once let go of our orbit. Here is what makes this land as something close to unsettling. Jupiter does not know we are here. It is not pulling on us on purpose, or with any awareness, or with any regard for what its pull does to the fragile film of life on the small world it is reshaping. It is simply a mass, enormous and indifferent, following its own orbit around the Sun, and the consequence of that mass is that our orbit bends to its influence. The two biggest planets in the solar system have a measurable, ongoing grip on whether your part of the world is buried under ice or open to the sky. They have had that grip the entire time life has existed here. They have it right now, tonight, as you listen, and they have no idea that anything down here depends on them at all. This is the emotional core of the whole story, so let me say it as directly as I can. The stable, mild climate that allowed everything you think of as human life, the settled weather that let our ancestors stop chasing herds across the tundra and start growing wheat and building the first towns, was not something the Earth guaranteed us. It was handed to us. And part of what shaped it, Part of what set the length and the timing of the warm window we happened to be born into was where these two enormous, uncaring worlds had nudged our orbit. The giants set the room temperature of the planet across geological time. We simply walked into the room and got comfortable, with no idea who was holding the thermostat. We tend to imagine that we are the main characters of the Earth story, that the planet is a stage set for us, and that its conditions are in some sense about us. This is the thought that Jupiter quietly dismantles. The forces that decide the largest features of our climate over the long run are not about us at all. They are the byproducts of two giant planets going about their orbits, colossal and blind, and our entire civilization exists in the narrow band of conditions those forces happen to allow. We are not the authors of our climate. We are tenants in a house whose foundations shift on a schedule we can barely perceive, and the landlords are two worlds we will never touch. There is a strange kind of humility that comes from looking at Jupiter this way, and it is not the same as fear. The point is not that Jupiter is about to do something violent to us. As we'll see, the timescales here are so slow that nothing dramatic is coming in any human lifetime. The point is smaller and stranger than fear. It is the simple recognition that the sky over your head, the mild sky that made your entire world possible, was arranged by a force you had no part in and no power over, and that the arrangement could have been otherwise. You're comfortable tonight in part because two distant giants happened to leave the Earth's orbit in a shape that allowed it. That is not destiny. That is closer to luck. It is worth being precise about what kind of luck this is, because it is not the luck of a single lucky roll. It is the luck of arriving at the right moment in a very long story. The Earth has swung through the ice and back many times, and the warm windows between the glaciations are only a fraction of the whole cycle. Most of the distant past of the northern world was colder and harder than the world we know. If you scattered human beings at random across the last million years, most of them would open their eyes into a world of advancing ice, not the mild and open one we happen to inhabit. We did not land in the cold part. We landed in the warm part, in the open pores, in exactly the stretch of the rhythm that allowed settled life to take hold. That is the shape of the luck. Not that the giants were kind, because they are not kind and not cruel and not anything at all, but that our brief moment fell where it fell on their long, slow wheel. The warmth was always going to come and go. We simply happened to arrive while it was here. But Jupiter is only one of the two hands, and if you write off the second one as the minor partner, just because it is lighter, you will miss something important about how this machine actually works. Saturn is smaller than Jupiter, far lighter, and much farther away, and by every obvious measure it should matter less. And yet Saturn matters out of all proportion to its size, for a reason that has nothing to do with its mass and everything to do with rhythm. To understand why the second giant punches so far above its weight, we have to look at the strange, slow conversation that Jupiter and Saturn have been having with each other for the entire history of the solar system. Part 7. The Second Author. Saturn is the lighter of the two giants, and by ordinary reasoning it should be the lesser partner in every way. It carries about 95 times the mass of the Earth, which is enormous by any human standard, but it is still far short of Jupiter, and it orbits much farther out, nearly twice as distant from the Sun. Distance weakens gravity, and lower mass weakens it further, so you might expect Saturn to be almost an afterthought in the shaping of Earth's orbit, a footnote next to its larger sibling. That expectation turns out to be wrong, and the reason it is wrong is one of the more elegant things in the whole solar system. Start with what Saturn does have, which is patience and persistence. Far away does not mean harmless when you're dealing with a force that never switches off, and a span of time measured in tens of thousands of years. Saturn's pull on the Earth, at any single moment, is faint, but that faint pull is applied steadily, in the same patterns, again and again, across ages so long that the smallness of each individual tug stops mattering. What matters is the accumulation. A weak force, repeated in the right rhythm for long enough, can reshape an orbit just as surely as a strong one, because the orbit remembers every nudge and adds them all together. Here is an image to hold on to for the rest of the night, because we will come back to it. Picture Earth's orbit as a loop of wire, a thin ring you could hold in your hands. Now picture Jupiter and Saturn as two slow hands resting on that loop, bending it. One hand pulls the loop a little more oval. The other, over thousands of years, eases it back toward round. Neither hand is rushing. Neither hand ever presses hard. But neither one ever lets go and neither one ever tires, and between them they keep the loop of wire slowly flexing in and out of shape, breathing between rounder and more stretched on a cycle that runs about 100,000 years long. That flexing loop is Earth's orbit, and that 100,000-year breath is one of the strongest beats in the entire Ice Age record. Notice what this means about the two giants. They are not a minor influence on Earth's climate that we are dressing up for dramatic effect. They are, in a real and measurable sense, the authors of one of its central rhythms, the 100,000-year cycle that shows up so clearly in the record of the ice. The beat that dominates the last million years of glaciation corresponds closely to the cycle over which Jupiter and Saturn's combined gravity stretches and relaxes the shape of our orbit. When we read that beat out of the rocks, we are, in a sense, reading the signature of two planets. The giants left their fingerprints on the climate, and the fingerprints are still there to be found. Saturn's role in this is what makes it more than a footnote. Even though it is lighter than Jupiter, Saturn is a full partner in bending the loop, and the reason comes down to how the two giants work together, rather than how much each one weighs on its own. If Saturn were simply a smaller version of Jupiter, tugging randomly and independently, its lighter mass would indeed make it the junior partner. But Saturn does not tug randomly. Saturn tugs in time with Jupiter, in a coordinated rhythm that lets the two of them accomplish together what neither could accomplish alone. And a coordinated push, delivered at exactly the right moment over and over, is far more powerful than its size alone would suggest. There is a quiet menace to Saturn that has nothing to do with its gravity and everything to do with how strange a world it is, and it is worth pausing on because it sharpens the sense of what these authors of our climate actually are. Saturn is so light for its enormous size that its average density is less than the density of water. If you could somehow find an ocean large enough to hold it, Saturn would float. The second largest planet in the solar system, a world nearly 10 times the width of the Earth, is in principle buoyant. It is a giant made of almost nothing, a colossal ball of gas so diffuse that it weighs less, ounce for ounce, than the water in your glass. And yet that airy, almost weightless giant still has enough gravitational reach to help tilt the balance between ice and open ground on a world it will never come anywhere near. There is something genuinely strange about the pairing when you hold both giants in mind at once. The two objects that between them help decide part of Earth's fate are a planet you could never float a boat on, because it has no surface at all and would crush you long before you reached one, and a planet that would itself float in a bathtub if only the bathtub were large enough. One is the densest and heaviest concentration of planetary mass in the solar system. The other is so wispy it would drift on water, and these two mismatched giants, the crusher and the floater, work together across the emptiness with a patience no living thing could match, bending the loop of Earth's orbit between them. This is why it will not do to think of Saturn as a lesser Jupiter. Saturn is a second author, writing in rhythm with the first, and the page they are both writing on is the climate of your planet. When Saturn leans on Earth's orbit, it is not acting as a bystander to Jupiter's larger pull. It is contributing a coordinated force of its own, timed to reinforce rather than cancel, and that timing is what turns a lighter planet into an equal partner in the shaping of the ice. To understand how two planets can push in time with each other across hundreds of millions of kilometers, we have to look at the slow gravitational conversation they have been holding since the solar system formed. A conversation with a rhythm as precise as a piece of music. It is called resonance, and it is the reason the second giant matters as much as the first. Part 8. Pushing in time. Resonance is the reason a small push can move a large thing, and everyone has felt it, whether or not they have ever heard the word. Think of a child on a swing. The child is heavy, the swing is long, and you're only using the strength of your arms, which is nowhere near enough to simply throw the child high into the air in a single motion. And yet the child goes higher and higher because you're not pushing randomly. You're pushing at exactly the right moment in each swing, adding a little energy at the same point in every cycle, and those small, perfectly timed pushes accumulate into a large motion. Push at the wrong times and your efforts cancel out into nothing. Push in rhythm and you can move something far heavier than your strength alone could ever move. Jupiter and Saturn are locked in exactly this kind of timed relationship, a slow, gravitational conversation that has been running for the entire history of the solar system. The rhythm between them is remarkably clean. For roughly every 5 trips that Jupiter makes around the Sun, Saturn makes almost exactly 2. 5 of Jupiter's years to 2 of Saturn's, over and over, a simple ratio buried in the motions of the 2 largest planets. Because that ratio is so nearly exact, the 2 giants keep returning to the same arrangement relative to each other. Their closest approaches, the moments when they line up on the same side of the Sun and pull on each other and on everything else most strongly, keep happening in nearly the same places again and again. This is what turns their pulls from noise into a signal. If Jupiter and Saturn passed each other at random, in different places each time, their combined effect on Earth's orbit would tend to average out, one tug cancelling another, leaving only a faint blur. But because their approaches recur in nearly the same configuration, their pulls do not cancel, they reinforce. Like the perfectly timed pushes on the swing, the giants' gravitational nudges land in a consistent rhythm, adding up in the same direction instead of scattering. 2 giants pushing in time with each other can move things that neither could move alone, and one of the things they move slowly and steadily is the shape of our orbit. Return to the loop of wire for a moment, because resonance is what puts the rhythm into the bending. It is not just that 2 hands are flexing the loop, it is that the 2 hands are coordinated, pressing and releasing in a steady, repeating pattern set by the 5-to-2 rhythm of the giants' orbits. That coordination is why the flexing of the loop has such a clean beat to it, why Earth's orbit breathes in and out of shape on a cycle regular enough to leave a mark in the rocks. The precision of the Ice Age rhythm is, in part, a reflection of the precision of the dance between Jupiter and Saturn. Their orderly conversation becomes the orderly pulse of the ice. This also solves the puzzle of Saturn's importance. Saturn matters as much as it does, despite being lighter than Jupiter, because it is not tugging alone. It is tugging in resonance with Jupiter, and resonance lets a smaller partner contribute a share of the effect far larger than its mass alone would grant. The child on the swing does not care how strong your arms are in absolute terms, it cares whether your pushes are timed right. In the same way, Earth's orbit does not simply respond to how heavy Saturn is, it responds to the fact that Saturn's pulls arrive in a rhythm coordinated with Jupiter's, and that coordination amplifies Saturn's influence out of proportion to its weight. The second author is not writing in the margins. It is writing on the same line as the first, in time with the first, and the sentence they compose together is the beat of the ice. There is a history to our knowing this, and it is worth a moment, because the rhythm between Jupiter and Saturn was one of the first things that ever forced astronomers to admit the solar system was not a simple clock. For a long time, careful observers noticed something troubling in the motions of the 2 giants. Jupiter seemed to be slowly speeding up in its orbit, and Saturn slowly slowing down, drifting away from where the tidy calculations said they should be. For decades it looked as though the 2 largest planets might be quietly falling out of their arrangement, as though the solar system itself might not be stable. The puzzle was serious enough that some of the greatest mathematicians of their age spent years on it, and the resolution, when it came, was the discovery of exactly the rhythm we have been describing. The apparent drift was not a slow unravelling at all. It was one long, slow swing of the 5-to-2 beat, a gradual back and forth in the giants' positions that takes centuries to complete and then reverses over and over perfectly stable across the ages. What had looked like the machine coming apart was really just the machine breathing. The giants were not drifting away from each other, they were keeping time, on a beat so slow that even a lifetime of careful watching caught only a fragment of it. There is something almost musical about this, and it is worth letting the strangeness of it register. 2 planets, separated by hundreds of millions of kilometres of empty space, have settled over billions of years into a shared rhythm, a 5-to-2 beat that keeps them returning to the same arrangement, and that shared rhythm reaches all the way to the Earth and helps set the timing of when our continents freeze. The solar system is not a set of isolated worlds each doing its own thing. It is more like an ensemble, its largest members keeping time with each other, and the smaller worlds, ours included, living inside the rhythm the giants keep. Consider how long this has been going on without any awareness on anyone's part. The 5-to-2 conversation between Jupiter and Saturn did not begin when we discovered it. It has been running since the planets settled into their orbits, more than 4 billion years ago, and it will keep running for billions of years more. For almost the entire span of that conversation, there was no one on Earth to hear it, and even once there were people, it took until the last century for anyone to work out that the rhythm existed at all. The giants have been keeping time in the dark, in a duet of gravity, and the beat of that duet has been printed onto our climate the whole while, waiting for someone to notice. And notice we eventually did, which is the part of this story that turns it from a beautiful idea into hard science. It would be one thing to say that the giants shape our orbit and simply ask you to take it on faith or on the strength of an elegant argument. It is another thing entirely to be able to prove it, to show that the rhythm of the giants really is written into the physical record of the planet, exactly where the theory says it should be. Because the truly remarkable thing about all of this is not just that the math works. It is that when we went looking for the giants' fingerprints in the actual body of the Earth, in the mud of the ocean floor and the ancient ice of the poles, we found them. We did not invent this rhythm and impose it on the world. We dug it up. Part 9. We dug up the clock. The theory could have remained just a theory, and for a long time it very nearly did. Milankovitch had shown, with his mountain of hand calculations, that the geometry of Earth's motion should produce a rhythm in the ice. But showing that something should happen is not the same as proving that it did. His idea rested on pencil and paper arithmetic about distant planets and slowly drifting orbits, and to many scientists that felt far too clean, far too abstract, to explain something as tangled and messy as the climate of an entire world. Milankovitch died in 1958, decades before the tools existed to properly test what he had done, and for years afterward plenty of researchers doubted him. The idea was elegant, but elegance is not evidence. What changed everything was the realization that the proof, if it existed at all, would not be found in the sky. It would be found in the ground. If the giants and the geometry really had been pacing the ice ages for millions of years, then the climate itself would have recorded that rhythm faithfully in every layer of material that slowly piled up over those ages. The Earth keeps its own diary, in the mud of the ocean floor and the ice of the poles, and if the rhythm was real, it would be written there. So the test of a theory about the motions of Jupiter and Saturn came down to something very humble. It came down to drilling into mud and ice and counting the layers. The evidence rests on two separate legs, and it is the fact that they agree that makes the case so strong. The first leg is the mathematics, carried far beyond anything Milankovitch could have done by hand. Scientists now build detailed models of the entire solar system, every major body and the gravity acting between all of them, and then let those models run forward and backward across millions of years, tracing the orbits step by step. They do not put the rhythms in by hand. They do not tell the model when the ice should come. They simply let the planets pull on each other according to the laws of gravity, and they watch what happens to Earth's orbit. And what happens is that the long cycles emerge on their own. The shape of Earth's orbit rises and falls in waves, with periods near 100,000 and 400,000 years, and those numbers fall right out of the combined pull of Jupiter and Saturn. The giant's influence is not assumed by the model. It appears in the model unbidden, exactly as the theory says it should. But a simulation, however sophisticated, is still a model, and a model could in principle be wrong, capturing the math while missing something real about the world. This is why the second leg matters so much, and it is the one that gives the whole story its weight. The second leg is the physical record, the rhythm written into the actual body of the Earth. When you drill down into ancient layers of seafloor sediment, or into the polar ice that has been piling up for hundreds of thousands of years, you find the climate cycles preserved like rings in a tree. Bands of warm and cold, wet and dry, stacked one on top of another in repeating patterns. And when scientists measure the spacing of those bands, the orbital rhythms are right there in the stone and the ice, the same beats the mathematics predicts. Come down with me into one of these records for a moment, into a core of ice pulled from far beneath the surface of Antarctica. You're looking at a long cylinder of ancient ice, drilled from the depths of the sheet and lifted carefully into the light, and as you move your eye down its length you're moving backward through time. Near the top is snow that fell not long ago. But as you descend, each band beneath the last is older, compressed, holding the frozen breath of a world that existed thousands of years before you were born. The layers are not uniform. Some bands mark warmer stretches, some colder, and they repeat over and over in a rhythm you can almost feel with your fingertips as you trace down the core. Here is a warm band, then a long cold one, then warm again, in a pattern that keeps time. You're not reading a story someone wrote. You're reading a record the planet kept, unwitnessed, for 100,000 years and more, and pressed into that ice is the beat of the giants, the same 100,000-year pulse the mathematics predicts, laid down layer by layer long before anyone was alive to read a single line of it. The moment those two legs were shown to agree is one of the quiet turning points in the history of science, and it has a date. In 1976, a team led by the scientists James Hayes, John Imbrie, and Nicholas Shackleton published an analysis of long cores of seafloor sediment, records that stretched back almost 500,000 years. They measured the climate rhythms buried in those layers, and there they were, the exact periods that Milankovitch's geometry had predicted. The cycle of the tilt, near 41,000 years. The cycle of the wobble, near 23,000. The cycle of the orbital stretch, near 100,000. All three, present in the mud, in the right proportions, right where the theory said they had to be. The paper that reported this carried a title that said the quiet part out loud. It called the orbital cycles the pacemaker of the ice ages. A pacemaker is a thing that sets the rhythm of a heart, and that is exactly the claim, that the slow geometry of Earth's motion, driven in large part by the gravity of the giants, sets the rhythm of the ice. A man with a pencil had heard the heartbeat of the ice ages decades before anyone could confirm it, and the planet had been keeping that exact beat all along quietly, in its mud and its ice, waiting. That is the thing that lands hardest for me, and I want to make sure it lands for you too. We did not invent these cycles. We dug them up. They were waiting in the geology, in the ice cores pulled from beneath Antarctica, in the layered cliffs of ancient seabed exposed to the air. The rhythm was there before we were, a signature left by a clock running far out in the dark, and all we did was finally learn to read it. The rocks remember Jupiter and Saturn, even though no single human being ever could, because no human life is long enough to feel a beat that takes 100,000 years to complete. The record outlives us, and it holds the memory of the giants for us, because we could never hold it ourselves. And once you accept that the giants really are keeping this rhythm, a natural curiosity takes hold about the larger of the two authors. We have talked about Jupiter's mass, its reach, its gravity. But the planet doing so much of this work is even stranger up close than it is from a distance, stranger than almost anyone imagines, and to really feel what kind of object has its hand on our climate, you have to stop thinking of Jupiter as a bright dot in the sky, and start thinking of it as a place you could fall into, a place that would never, at any depth, let you stand. Part 10. Inside the Giant. Jupiter has no surface. That is the first thing to understand, and it is genuinely difficult to hold in the mind, because everything in our experience tells us that a world is something you can stand on. The Earth has ground, the Moon has ground, Mars has ground, but Jupiter has none. There is no line anywhere on Jupiter where the atmosphere ends and solid land begins. If you tried to land on it, there would be nothing to land on. You would simply keep falling, down and down into a world that only gets thicker and heavier the farther down you go, and never once offers you a floor. Let yourself fall into it for a moment and feel what happens. You drop first through bands of pale ammonia clouds, the cream and rust-coloured stripes you can see through a backyard telescope, and for a while it feels almost like descending through the sky of a strange planet. But there is no ground waiting beneath the clouds. Instead, the air around you simply thickens. You fall into a hydrogen atmosphere that grows denser and hotter the further down you go, pressing in on you from every side until the gas stops behaving like gas at all. Thousands of kilometres down, several thousand miles beneath where you entered, the pressure has become so crushing that the hydrogen around you is squeezed into a liquid. Keep falling, and it becomes stranger still, because the liquid hydrogen is compressed so hard that it turns into a metal. You are now sinking through an ocean of liquid metallic hydrogen, a sea of a substance that does not exist anywhere on Earth, wrapping the planet's core in a shell of shining, electrically conducting liquid. There is no moment where you arrive anywhere. There is only more and worse and heavier all the way down, the pressure climbing toward millions of times what you feel at sea level, enough to flatten any machine we could ever build long before it reached even the halfway point. It is worth pausing on that ocean of metallic hydrogen, because it is not just a curiosity of pressure. It is the reason Jupiter has the largest magnetic field of any planet in the solar system. On Earth, our magnetic field is generated by molten metal churning in the core, and it is strong enough to swing a compass needle and to shield us, in part, from the stream of particles the sun throws off. Jupiter does the same thing on a scale that makes ours look tiny, except that the churning metal is not iron. It is hydrogen, squeezed so hard that it conducts electricity like a metal, sloshing and circulating as the planet spins on its 10-hour day. That combination, an enormous ocean of electrically conducting liquid stirred by the fastest rotation of any planet, generates a magnetic field so large that it would dominate our night sky if we could only see it. So the same crushing pressure that would destroy any probe on the way down is also the engine of Jupiter's magnetism. The planet's most hidden layer, the one we can never reach, reaches back out across space in a magnetic field larger than the Sun as it appears from Earth. Nothing about Jupiter stays where you put it. Its interior is untouchable, and yet that interior is exactly what produces the enormous invisible presence surrounding the planet, the presence that traps the radiation that kills our machines. The unreachable center is the source of the outermost reach. We have never touched Jupiter's core, and with any technology we can presently imagine, we never will. The pressures and temperatures on the way down would destroy any probe long before it arrived. Everything we know about the inside of this planet, we have learned from the outside, by watching how its gravity behaves, how its magnetism reaches out, how it bends the paths of the spacecraft we send skimming past it. The interior of Jupiter is one of the most hostile places in the solar system, a slow crush of metallic liquid and unimaginable pressure, and it is permanently beyond our reach. And yet it is this world, this crushing, surfaceless giant, that has its faint hand on whether our continents freeze. Here is a fact about Jupiter worth keeping, because it deepens the strangeness. Jupiter gives off more heat than it receives from the Sun. Every other consideration aside, the planet is quietly glowing with warmth from within, radiating more energy into space than sunlight delivers to it. That heat is not borrowed from the Sun. It is left over from Jupiter's own birth, energy stored up 4.5 billion years ago when the planet first formed and squeezed itself together under its own enormous gravity. Jupiter is still, very gently, contracting inward under that gravity, shrinking by a tiny amount over long stretches of time, and that slow collapse releases heat. So the planet glows faintly with the memory of how it was made. It has been cooling at that crawl for the entire age of the solar system, and it still is not finished. Hold that whole picture in your mind at once because it is almost too much to carry. Here is a planet so enormous that its gravity bends the orbit of a world hundreds of millions of kilometers away. A planet with no surface, wrapped in an ocean of metallic hydrogen, glowing softly with the leftover warmth of its own formation. A planet whose gravity is quietly helping to decide when ice swallows our continents. And most people who have ever lived went their whole lives without knowing that a single piece of it was happening above them, that the bright dot in the evening sky was doing anything at all to the ground beneath their feet. There is another side to Jupiter that makes the slow, patient way it works on our climate land even harder by contrast, and it has to do with speed. For all that its influence on us unfolds across 100,000 years, Jupiter itself is anything but slow. It spins faster than any other planet in the solar system. A full day on Jupiter, one complete rotation, lasts under 10 hours. Sit with that against its size. This is a ball more than 11 times wider than the Earth, with the mass of more than 300 Earths, and it whirls around so fast that a single one of its days is shorter than the length of a night's sleep. That ferocious spin has left a visible mark on the planet's shape. Jupiter is not a perfect sphere. It visibly bulges at its equator, squashed like a ball that someone has sat on, because it is spinning hard enough to fling its own middle outward into space. The same planet, in other words, does one of the fastest things in the solar system and one of the slowest at the same time. The frantic 10-hour spin you could watch through a telescope over the course of a single afternoon, the cloud bands visibly rolling past, and the grip on Earth's orbit that takes 100,000 years to complete a single swing. Jupiter is violent and patient all at once, and it is the patient side, the almost imperceptibly slow side, that moves walls of ice across our continents. The most famous feature on the planet ties these two faces together, the speed and the scale. Jupiter carries a single storm, the Great Red Spot, that has been raging for centuries, long enough that people have been watching it through telescopes for generations without seeing it end. It is a swirling vortex wide enough to swallow the entire Earth, a storm larger than our whole planet that has outlived every person who has ever pointed a telescope at it. Winds in Jupiter's cloud bands tear along at hundreds of kilometers an hour, hundreds of miles an hour, faster than any storm the Earth has ever produced. The loud part of Jupiter, the spinning and the storms and the great red eye staring out of the clouds, is genuinely one of the most violent shows in the solar system. And yet the loud part is not the important part. The important part is the quiet force you cannot see at all, the slow, patient pull on a small blue world hundreds of millions of kilometers away, a pull that is completely indifferent to the storms raging on Jupiter's own surface. That is the thing about this planet that is hard to shake once you have seen it. The spectacle is not the point. The point is the silence underneath the spectacle, the gravity that just keeps reaching, and has kept reaching the whole time we have existed. To learn even this much about what lies inside Jupiter, though, we had to do something extraordinary. We had to throw machines across the solar system, one after another, on journeys with no return, just to get close enough to a planet that does everything in its power to destroy anything that approaches it. Part 11. The machines we threw at it. Everything we know about Jupiter up close, we learned by sending machines to it on one-way trips. There is no other way to study a planet like this. You cannot bring a piece of it home, you cannot land on it and walk around. You can only hurl a spacecraft across hundreds of millions of kilometers of empty space, aim it with enormous care, and hope it survives long enough to send something back before the planet destroys it. And Jupiter does everything in its power to destroy visitors, because surrounding it is not just crushing gravity, but an invisible storm of radiation fierce enough to kill electronics outright. The first machine to arrive was a small probe called Pioneer 10, which reached Jupiter in 1973 after a journey of nearly 2 years. It did something nobody was entirely sure it could survive. It flew straight through Jupiter's radiation belts, an unseen tempest of charged particles trapped by the planet's colossal magnetic field, and it lived just long enough to send back the first close-up photographs of the giant ever taken. Before Pioneer, Jupiter was a face in a telescope. After Pioneer, it was a place we had visited, however briefly, and lived to hear from. That magnetic field is worth pausing on, because it is one of the most enormous structures in the entire solar system. Jupiter's magnetosphere, the region of space its magnetic field controls, is the largest single structure orbiting the Sun apart from the Sun's own reach. If your eyes could somehow see it from Earth, glowing in the night sky, it would appear larger than the full moon. It is an unseen bubble so wide that several of Jupiter's moons orbit entirely inside it, a magnetic empire wrapped around the planet, and it is the source of the radiation that makes approaching Jupiter so dangerous. The giant does not merely have gravity that reaches across the solar system, it has a magnetic presence so large it would dominate our sky if we could only see it. After Pioneer came the 2 Voyager spacecraft which reached Jupiter in 1979, and they caught the planet in motion in a way no still photograph ever could. They filmed the storm bands flowing, they watched the great red spot churn, and they discovered something that nobody had expected on one of Jupiter's moons. A small world called Io, orbiting close to the giant, turned out to be covered in active volcanoes spraying sulfur high into space. This was genuinely shocking at the time because a small moon, far from the sun, should be a dead and frozen rock. There should be nothing to keep its insides warm. Instead, Io was the most volcanically active body anyone had ever seen. The explanation reveals just how powerful Jupiter's gravity really is. Io does not stay molten because of the sun. It stays molten because Jupiter is squeezing it. As Io orbits, the giant's gravity needs the little moon, stretching and releasing it on every pass, and that constant flexing generates friction far inside Io, and the friction keeps its interior hot enough to erupt. Jupiter is, in effect, torturing its own moon into staying alive, wringing heat out of it with sheer gravitational force. Even Jupiter's own family does not get to rest. If you want to understand what it means for this planet to have its hand on our orbit, look at what its hand does to a moon right beside it, keeping an entire world molten just by pulling on it. The mission that committed most fully to Jupiter was called Galileo, which reached the planet in 1995 and then spent years circling it, studying the giant and its moons in detail. But on the way in, Galileo did something that still stops me when I think about it. It carried a smaller probe, and it dropped that probe straight into Jupiter's atmosphere deliberately to taste the planet during the fall. Picture the probe in its final hour. It comes screaming into the top of Jupiter's atmosphere behind a heat shield that flares to thousands of degrees as it slams into the gas, a tiny machine riding a shell of fire into a world with no bottom. The shield does its work, the probe slows, and a parachute opens. Now it is drifting downward through the clouds of Jupiter, the first and only object from Earth ever to fall into the atmosphere of a giant planet, and it is radioing home as it goes. It sends back the temperature. It sends back the pressure. It sends back the chemistry of the air around it, real measurements from inside the giant, streaming up and out across 500 million kilometers of space to the waiting antennas on Earth. For 58 minutes it keeps falling and keeps talking, farther into the crushing dark, the pressure and the heat climbing with every kilometer. And then the rising heat and pressure finally overwhelm it, and the transmitter fails, and the signal stops. Within hours the probe itself is gone entirely, melted and then vaporized somewhere in the crushing atmosphere. It did not crash into anything, because there was nothing to crash into. It simply fell until it stopped existing, swallowed by the planet it had come all that way to study. 58 minutes of data from inside a giant planet, bought at the price of the machine that gathered it. That is what it costs to learn about Jupiter from the inside, and even then we only reached a shallow layer near the top. The core stayed as untouchable as ever. Think about what each of these journeys actually demanded. To reach Jupiter at all, a spacecraft has to be flung across hundreds of millions of kilometers of empty space, on a path calculated years in advance, aimed not at where the planet is, but at where the planet will be after a journey lasting years. There is no steering it home again. There is no second chance if the aim is wrong. Every one of these machines was built on Earth by people who knew they would never see it again, packed with instruments, and thrown into the dark toward a target so distant that the radio signals it sent back took most of an hour to arrive. And then, at the end of that enormous journey, the reward was to fly into the most dangerous environment in the solar system, a storm of radiation fierce enough to kill electronics wrapped around a planet that offers nothing to land on and nothing to bring home. That we have done this at all, 4 times over and counting, is one of the quieter triumphs of our species. We could not go ourselves, so we built machines to go in our place, and we sent them on one-way trips into the dark, purely to learn what a giant planet is made of and how it behaves. The giant does not know they came, but we know. And a little more of what we understand about the hand on our climate was bought, each time, at the price of a machine that never returned. And right now, today, a spacecraft called Juno is still there, looping over Jupiter's poles on long, careful orbits, its most sensitive electronics sealed inside a vault of titanium to shield them from the radiation storm that would otherwise kill them. Juno peers farther into the planet than anything before it, reading its gravity and its magnetism to map what lies beneath the clouds, and it has already overturned something we thought we knew. Jupiter's core, it turns out, is not the neat, solid ball that scientists expected to find at the centre. It appears to be something stranger, a fuzzy, smeared-out core that blurs gradually into the layers of metallic hydrogen above it, with no sharp boundary at all. Even the centre of Jupiter refuses to be simple. Every one of these machines, Pioneer and the Voyagers and Galileo and Juno, was a gamble, thrown across hundreds of millions of kilometres toward a planet that does not want visitors and punishes those it receives. And every one of them came back with the same message. Jupiter is bigger, stranger, and more powerful than the calm picture in the textbook ever suggested. This is the object with its hand on our climate. Not a tidy diagram of a planet, but a surfaceless, radiation-wrapped, moon-torturing giant that destroys the very instruments we send to understand it, and its gentlest act, the softest thing it does, is the slow bending of our orbit that helps decide the fate of the ice. Part 12. The Warm Window. Everything you think of as human civilization happened inside a single warm interval. That is the implication that has been building underneath this whole story, and it is time to let it land fully. We did not build our world across the whole sweep of the ice ages. We built it entirely inside one narrow warm window between glaciations, the calm stretch that followed the last retreat of the ice, and every piece of what we call human achievement fits inside that single interval with room to spare. Trace the timing, because it is humbling. Our ancestors spent the long cold of the last glaciation as small bands of hunters, following herds across a frozen and difficult world. Then, roughly 10,000 years ago, the ice retreated, The climate settled into a warm and steady phase, and almost immediately, in the scale of these things, everything changed. People stopped chasing herds across the tundra and settled down. They began to grow wheat. They built the first towns, and from that settling came everything that followed: farming and cities and writing, every empire that ever rose and fell, every invention from the first plough to the machine you are listening to me on right now. All of it fits inside one warm interval between ice ages. And the length and warmth of that interval, the very stability that let us build, was shaped in part by where Jupiter and Saturn have nudged our orbit. The giants set the room temperature of the planet across the long stretches of time by helping determine the shape of the orbit and thus the pattern of the ice. We came out of the last glaciation into a warm, steady window, and we constructed the entirety of human civilization inside it, and we did so with no idea whatsoever who was holding the thermostat. The giants set the temperature of the room. We simply walked in and got comfortable. This is the sense in which we are tenants rather than owners. Return to that word because it is the truest one I know for our situation. A tenant lives in a house but does not control its foundations. We live on this planet, we have covered it with our works, we speak of it as our world, but the most basic conditions of its climate over the long run are set by forces entirely outside our control, by the slow shifting of an orbit that two distant giants bend between them. We are tenants in a house whose foundations shift on a schedule we can barely perceive, paying our rent in a currency of time we do not even know we owe. The warmth that built our entire world was an arrangement of gravity we had no vote in and no power over. Let me try to make the scale of that arrangement something your own body can feel, because the numbers go numb if you do not anchor them. The main beat of Earth's orbital cycle runs about 100,000 years long. To live through one full swing of that cycle, you would need to be born today and keep living, awake and aware for 100,000 years without stopping. Now set the whole of recorded human history against that span. Every war, every empire that ever rose and fell, every invention from the first wheel to the rocket that left the Earth, all of it fits inside that single 100,000-year swing several times over, with room to spare. The entire story we tell ourselves about who we are is a thin sliver of one turn of a wheel that the giants started spinning before our species existed. You, and everyone you will ever know, are living through one narrow slice of one rotation of that wheel. On a human timescale, nothing about it visibly changes. Almost everyone who has ever lived was born somewhere on that slow turn and felt nothing move beneath them, because the beat is so much longer than a life that a life cannot contain enough of it to notice. We do not experience the wheel turning. We experience a sky that seems permanently fixed, a climate that seems like simply the way things are. But it is not fixed, and it is not simply the way things are. It is one position on a wheel, and we happen to be alive at a particular point on that wheel, in the warm part, in the open window between the ice. Here is the part that makes it personal, and it is not a matter of fear. We happen to be alive in the warm interval, the open stretch between glaciations, not because we earned it or chose it or deserved it, but because of where the wheel happens to sit right now. Pure timing handed us a stable sky to build under. We got the calm stretch. We got the thaw. If our species had arisen at a different point on the wheel, in the depths of a glaciation, the whole story of human civilization might have been impossible, or might have taken a form we cannot even imagine. That we got the warm window is not destiny. It is closer to luck. But it is the kind of luck worth stopping to feel. There is a quiet dignity available in seeing this clearly, and it is the opposite of despair. The knowledge that we did not control the warmth that made us does not have to diminish us. It can do something gentler. It can locate us, honestly, in a story much larger than ourselves, and let us feel the improbability of our own comfortable moment. The stable sky that let your ancestors stop running and start building was handed to you by the slow turning of orbits shaped by worlds you will never see. To know that, and to feel the luck of it, is not a burden. It is a kind of gratitude that only becomes possible once you understand who was holding the thermostat all along. And yet there is one more layer to Jupiter that we have not touched, and it is the one that makes the giant feel less like a planet and more like a slow, immense force that deserves genuine respect. Because the same gravity that gently bends our orbit and hands us our warm window is, in the far reaches of time, capable of something far less gentle. The grip that gives us the ice ages is only the mildest edge of a power with a much wider and much darker range. Part 13. The slow engine. Jupiter's grip does not stop at gently shaping our orbit. That gentle bending, the slow flex of the loop of wire that gives us the rhythm of the ice, is the mildest thing the giant does. But run the solar system forward far enough in the same kinds of simulations that reveal the orbital cycles, push them not thousands or millions but billions of years into the future, and the picture stops being so orderly. The tidy, predictable clockwork begins to come apart because gravity, over long enough spans, does not only keep rhythms, it can also build instabilities. The way it happens is subtle. Across billions of years, the tiny gravitational tugs between the planets, the same faint pulls that bend Earth's orbit so usefully, can accumulate in ways that feed on themselves rather than averaging out. A small nudge, repeated in the wrong rhythm, can grow instead of settling. And in some of these long-range models, the planet that suffers most is Mercury, the smallest planet and the one closest to the Sun. In a fraction of the simulated futures, a slow resonance between Mercury and Jupiter stretches Mercury's orbit further and further, more and more oval, until the little planet's path becomes unstable and it is flung loose. In the most extreme outcomes, Mercury collides with Venus, or falls into the Sun, or is thrown across the inner solar system entirely. Let me be careful here, because this is exactly the kind of fact that gets torn out of context and turned into a doomsday headline. The odds of this happening are low, somewhere around 1% over the next 5 billion years. And 5 billion years is a span of time so enormous that it runs out past the point where the Sun itself will begin to die, swelling and changing in ways that will reshape the entire inner solar system regardless. This is not a warning about anyone's lifetime, or anyone's civilization, or any future that human beings will ever have to face. Mercury is not about to be flung anywhere. The instability is a rare outcome, buried far in a future so distant that the Sun's own death arrives first. But the fact tells you exactly what kind of object Jupiter is, and that is why it is worth knowing. Jupiter is not a neighbour. It is not a companion planet quietly sharing the solar system with the rest of us. It is a slow, colossal engine of gravity that has been steering the fates of the other planets since before the Earth had oceans, and that will keep steering them long after the Sun begins to fail. Its influence on our ice ages, the thing this entire story has been about, is only the part of that power gentle enough to let us survive underneath it. The same force that hands us our warm window could, in a rare and distant future, unmake the orbit of an entire planet. We live in the soft edge of something with a very hard range. Return for a moment to the loop of wire and the two slow hands. When we first imagined Jupiter and Saturn bending Earth's orbit, the image was almost gentle, two patient hands easing a ring in and out of shape. But you should now understand that the same hands, given enough time, could bend a loop until it broke. What saves us is not that the giants are gentle. It is that the particular rhythm they keep with the Earth happens to fall in the safe range, the range that bends our orbit without shattering it. We survive underneath Jupiter not because Jupiter is kind, but because the geometry that connects us to it sits, for now, in a stable pocket. The engine that steers the planet steers us softly. It did not have to. Picture the giant one more time up close, holding all of this in mind at once. Even though it would kill you 100 different ways, even though you could never stand on it, because there is nothing to stand on, imagine floating for a moment in Jupiter's upper clouds. The thing that would overwhelm you there is not the cold or the pressure. It is the speed and the scale together. Storms wider than entire planets would roll beneath you. The great red spot alone, that single swirling vortex, has been raging for centuries and is wide enough to swallow the Earth whole, a storm that has outlived every person who ever watched it. Winds in the cloud bands would tear past at hundreds of kilometers an hour, faster than any storm our planet has ever produced, and the whole enormous machine would spin through a complete day before you had finished a single night's sleep. And underneath all of that noise, all that motion and violence and scale, there is the silence, the slow, patient pull on a small blue world hundreds of millions of kilometers away, indifferent to the storms tearing across Jupiter's surface, indifferent to the ice it helps shape on ours. That is the thing about the giant that is hardest to shake once you have seen it. The loud part, the spin and the storms and the red-eye, is not the important part. The important part is the quiet force you cannot see at all, the one that has been with us the whole time, steering the fate of the ice with a patience no living thing could match. But if that slow engine is real, and its grip on our climate is real, a fair question arises, and it deserves an honest answer. If the giants can move the ice, should we be worried? Is something about to happen to us? To answer that honestly, we have to talk about two very different clocks. Part 14. Two clocks running. Before you go outside and stare nervously up at the sky, let me be honest with you, because this is exactly the kind of story that gets twisted into something it is not. The orbital cycles are slow. That word slow does not do justice to how slow they truly are. We're talking about tens of thousands of years for the rhythm to swing on its own, for the geometry to shift enough to push the world toward ice or away from it. This machine, the one built out of Jupiter and Saturn and the geometry of Earth's motion, is not about to drop an ice age on your grandchildren, or their grandchildren, or any generation you could put a name or a face to. Its hand moves across the calendar of geological time, not the calendar of a human life. Hold that firmly, because the whole point of understanding the giant's clock is to understand how slow it is. When the record shows the ice advancing and retreating, it is showing changes that unfold over thousands and tens of thousands of years, so gradual that no single generation living through them would ever perceive the trend. The snow that survives one summer more than it used to is not a catastrophe anyone could witness. It is the first faint increment of a change that would take 1,000 centuries to complete. The pacemaker of the ice ages beats once every tens of thousands of years, and on any timescale that matters to a person, or a nation, or a civilization, it is effectively standing still. There is, however, a faster and much closer force acting on the Earth's climate right now, and honesty requires naming it. The carbon we're pouring into the atmosphere works on a timescale of decades, not tens of thousands of years. It is a fast hand where the giants are a slow one. The orbital cycles and the changes we're making to the air are both real, and both act on the climate, but they run at completely different speeds, and it is important not to confuse them. The giant's clock is slow, so slow that it is almost a kind of stillness. What we're doing to the atmosphere is fast enough to matter within a single human life. To point at the giants and imagine they're about to freeze us, or to imagine that their slow rhythm has anything to say about the changes unfolding on the scale of decades, is to mix up two clocks that keep entirely different time. So the answer to the nervous question is reassuring in its way. Nothing about the orbital machine is poised to happen to you. The reset that the giants keep, the slow swing between ice and open ground, is not a countdown ticking toward your doorstep. It is a rhythm so gradual that it belongs to geology rather than to history, and it will go on beating its slow beat regardless of anything that happens in any human time frame. If you were looking for a reason to fear Jupiter, this is not it. The giant is not a threat hanging over your life. It is a clock, and its second hand takes 100,000 years to move. But here is the strange turn, the thing that stays with me long after the fear has been set aside. The unsettling part of this story was never the speed. It was never really about whether the ice was coming soon. The unsettling part is the indifference. This machine does not know we exist. It was turning long before there was anything alive on Earth to feel it, grinding through its slow cycle when the planet was young and lifeless, and it will keep turning long after the last trace of us is gone. It has no awareness of the civilization that grew up inside one of its warm windows. It has no regard for whether that civilization thrives or vanishes. It simply keeps time. Sit with the weight of that, because it is a different feeling than fear, and I think a heavier one. The warmth that built our entire world was an arrangement of gravity we had no vote in and no power over, arranged by forces that have no idea we're here, and would not alter their motion by the smallest fraction if we vanished tonight. We are tenants in a house whose foundations shift on a schedule we can barely perceive, and the landlords do not know they have tenants. There is no malice in it, and no kindness either. There is only the enormous, patient turning of orbits, and our small, warm moment happening to fall in a gap between the ice. This is the thing the giants force you to confront once you understand them properly. Not danger, not an ice age bearing down on the near future. Something quieter and heavier than any of that. The realization that the largest features of our world, the warmth that let us exist, the rhythm that will one day bring the ice back, are set by forces that are completely uninterested in us. The machine keeps time whether or not anyone is watching, and for almost the entire history of the Earth, no one was. The rhythm passed in total silence, unwitnessed, the ice coming and going with no mind anywhere to mark it. Which raises the last question worth asking tonight, and it is not a frightening one. It is almost the opposite. If the giants are so far away, and so indifferent, and so slow, then how did we ever come to know them at all? Part 15. The Reach Across the Dark. Consider how far away all of this is happening, because the distance is part of what makes it so strange. Light is the fastest thing there is, moving at about 300,000 kilometers every second, roughly 186,000 miles in the time it takes to say the word second. Nothing in the universe travels faster, and yet even at that impossible speed, sunlight takes more than 40 minutes to reach Jupiter. The giant sits, on average, around 778 million kilometers from the Sun, nearly 484 million miles out in the cold, so far that the light warming its cloud tops left the Sun the better part of an hour before it arrived. Let that distance sink in against everything we have said. When Jupiter pulls on the Earth, it is pulling across that entire gulf, across hundreds of millions of kilometers of empty space, a distance so large that light itself takes most of an hour to cross a good part of it. And still the pull lands, still the gravity reaches all the way in and helps decide whether the far north of our planet freezes. There is something almost impossible to accept about that, because our instincts insist that a force should fade to nothing across a distance that enormous. A shout dies within a few hundred meters, a light dims and vanishes. Surely we feel a pull from that far away should be nothing at all, but gravity does not fade the way our instincts insist it should. It weakens with distance, yes, spreading thinner the farther it travels, but it never drops to zero, and it never simply stops. It crosses the dark patiently, thinning but never breaking, and it never lets go. The gravity of Jupiter reaches across all those hundreds of millions of kilometers, faint but unbroken, and takes hold of our orbit and holds it, and has held it for 4.5 billion years without pause. Distance does not release us from the giant. It only stretches the thread. The thread itself never snaps. This is the quiet lesson underneath the whole story, and it is worth stating plainly. The things that shape our world most profoundly are not always the loud things, or the close things, or the fast things. Sometimes they are silent and unimaginably far away, and so slow that they seem not to be moving at all. Jupiter does not announce its grip on us. It does not flash or roar or send any signal we can feel. It simply sits out there in the dark, hundreds of millions of kilometers away, and reaches, and the reaching is enough to bend the path of our entire planet. Return one last time to the two faces of the giant, the loud one and the quiet one, because the distance sharpens the contrast between them. Up close, Jupiter is all spectacle, the 10-hour spin, the storms wider than worlds, the great red eye that has churned for centuries. If you could hang above its clouds, the noise and the scale and the speed would be overwhelming, the most violent show in the solar system. But none of that spectacle is what touches us. What touches us is the part that makes no show at all, the silent gravitational pull crossing all that emptiness to take hold of a small blue world it will never come near. The loud part is not the important part. The important part is the quiet reach across the dark, the one that has been holding us the entire time, and the reach has been holding us for far longer than any one warm window, far longer than the story of the last ice age alone would suggest. The record of the giant's work on our climate goes back further than most people ever imagine, and to feel the full patience of the thing, you have to widen the frame beyond the single glaciation our ancestors survived, and look at the whole long series of them, stretching back across millions of years, each one paced by the same slow hands. Part 16. A Rhythm Older Than Us. This is not the story of one ice age and one thaw. That is the mistake most of us carry, the sense that there was a single frozen chapter in the past and then the warm present. The truth is far more relentless. Over the last few million years, the Earth has swung into glaciation, and back out of it dozens of times, over and over, the ice advancing and retreating like a tide measured in tens of thousands of years. Each cold phase buried the northern continents, each warm phase released them, and then the ice returned and buried them again, cycle after cycle after cycle, for a span of time so long that our entire species is younger than the gap between two of its beats. Every one of those swings followed the same pacemaker. Each time the orbital geometry shifted, the northern summers cooled, the snow began to survive, and the ice grew. Then the geometry shifted back, the summers warmed, the ice melted, and the seas rose to drown the exposed land. The sheets came down over the same northern lands again and again, locking up so much water that sea levels fell by more than 100 meters, over 300 feet, each time exposing land bridges that early humans and countless other creatures walked across, and each time drowning them again when the warmth returned. The coastlines and islands and shallow seas of the world were carved in part by this rhythm, running out in the outer solar system, printed onto the geography of the Earth across millions of years. Now here is where the story turns from settled science into something still genuinely unsolved, because for all that we can read the beat, there is a piece of it we cannot fully explain. The strongest, clearest rhythm in the record of the last million years is the 100,000-year beat, the stretch of the orbit driven by Jupiter and Saturn. It dominates the ice ages of recent geological time, and yet, of the 3 orbital cycles, the stretch of the orbit is the one that changes the total sunlight reaching the Earth the least. The push it delivers is faint, fainter than the tug of the tilt or the wobble. The beat that shows up most powerfully in the ice corresponds to the weakest of the forces. Think about how odd that is. The loudest signal in the record is produced by the softest push. It is as though you found that the lowest note in a piece of music was being played by the quietest instrument in the room. The geometry of the orbit's stretch barely nudges the sunlight, and yet its rhythm rings out most clearly of all in the frozen record of the planet. Somehow, a faint 100,000-year push from the giants gets amplified, inside the machinery of the Earth's climate, into the dominant beat of the ice ages. And exactly how that amplification works, how a whisper of gravity becomes a wall of ice, is still not fully understood. Scientists have good ideas about the pieces involved. The Earth's own systems, the great ice sheets themselves, the carbon in the air, the dust and the oceans, all respond to the faint orbital push, and, in responding, magnify it. The ice sheets grow and feed their own growth. The carbon shifts and deepens the cooling. The climate has feedbacks, internal loops that can take a small nudge and swell it into an enormous effect. But the full accounting, the complete explanation of why the weakest orbital cycle produces the strongest climate rhythm, remains one of the genuine open problems in this field. We can hear the beat perfectly. We can point to the hands keeping it. We just cannot yet say in full how the faintest of their pushes becomes the thickest of the ice. This is the real core of the mystery, and I find it more interesting than any doomsday version could ever be. 2 things are true at once. The timing of the ice ages is written cleanly in the geometry of Earth's motion, shaped by 2 planets we will never visit, a fact so precise it appears in both the equations and the rocks. And at the same time, the strongest beat in that record comes from the weakest push, so that exactly how the giant's faint, patient pull becomes half a frozen planet is still, in part, hidden from us. The clock is real, its keepers are named, and still the mechanism that turns a small change in distant gravity into a continent of ice keeps part of itself concealed. There is one more twist in the record that makes the mystery sharper still, and it is the strangest detail of all. The pacemaker itself appears to have changed its beat once, without any change in the giants that keep it. If you look far enough back past the last million years and into the millions before, you find that the ice ages used to run on a different rhythm. For a long stretch of the distant past, the dominant beat was not the 100,000-year stretch of the orbit at all. It was the 41,000-year cycle of the tilt, the nodding of Earth's axis, ticking along as the main driver of the ice. And then, somewhere around 1 million years ago, the rhythm shifted. The 41,000-year beat gave way to the 100,000-year one, and the ice ages became longer and more severe, settling into the pattern we see in the recent record. Here is what makes that so strange. The orbital forcing did not change. Jupiter and Saturn kept the same time they had always kept. The tilt kept nodding on its same cycle. The orbit kept stretching on its same cycle. Nothing in the sky was different, and yet the Earth's response to that unchanging rhythm reorganized itself, switching from one beat to another, for reasons that are still argued over today. Something inside the planet's own climate machinery changed which of the giants' rhythms it chose to follow. We can see that it happened. We can date roughly when it happened. We cannot yet fully say why. The clock overhead never changed its ticking. The listener somehow changed which tick it followed. There is a kind of honesty in sitting with that, rather than pretending we understand more than we do. We know who is keeping time, and we can read the beat exactly, down to the length of each swing. But we cannot yet fully say how a whisper of gravity from 500 million miles away becomes ice above our streets. The rhythm is legible, and the mechanism is not, both at the same time, and that combination is far stranger and far more interesting than any simple answer would be. It means the story is not finished. It means there is still something out there, in the machinery connecting the giants to the ice, that we have heard but not yet understood. And the fact that we have gotten even this far, that we can name the rhythm and its authors at all, is itself the strangest and most hopeful part of the whole story. Part 17. How we learned to read it. Stop and consider what it took for us to know any of this, because it is easy to lose in the enormity of the subject. The rhythm is too slow for any human being to live through. No one has ever felt an ice age come. No one has ever watched the orbit stretch or the tilt nod or the wobble sweep around. These are changes that unfold across tens of thousands of years, far beyond the reach of a single life, or 100 lives, or the entire span of recorded history. By every ordinary measure, this rhythm should have been completely invisible to us, a beat too long and too quiet for any creature with a lifespan like ours to ever detect. And yet we detected it. That is the quietly astonishing thing at the centre of all this. A species that lives for a few decades, on a planet whose climate cycles take 100,000 years, somehow worked out the whole hidden machinery of the ice, from the geometry of its own orbit to the gravity of two distant giants keeping time in the dark. We did it without ever being able to see the thing directly. We did it by inference, by patience, by the slow accumulation of clues from wildly different sources, all pointing at the same answer. It began, in a sense, with a man and a pencil, filling notebooks with the sunlight of 100,000 years ago, chasing an idea most of his contemporaries thought too neat to be true. But it did not end there. It continued in the great simulations of the solar system, the models that let the planets pull on one another according to gravity, and watch the orbital cycles emerge on their own, unbidden, exactly as the pencil had predicted. And it was confirmed in the mud and the ice, in the long cores drilled from the seafloor and the depths of the polar sheets, where the rhythm of the giants lay preserved in bands of warm and cold, waiting for someone to measure the spacing and recognize the beat. 3 completely different windows onto the same hidden truth, and all 3 showed the same rhythm. We did not invent these cycles. I keep returning to that, because it is the part that gives me a kind of vertigo. We dug them up. They were waiting in the geology, in the ice cores pulled from beneath Antarctica, in the layered cliffs of ancient seabed, a signature left by a clock that had been running far out in the dark for millions of years before there was any mind on Earth to read it. The rocks remembered Jupiter and Saturn, even though no single human being ever could, because no human life is long enough to hold a beat that takes 100,000 years to complete. The Earth kept the record for us, faithfully, across ages, and all we had to do was learn its language. There is a strange dignity in being the part of the system that finally noticed. For almost the entire history of the Earth, the rhythm passed unwitnessed. The ice came and went, the orbit stretched and relaxed, the giants kept their patient time, and there was no one anywhere to mark a single beat of it. The machine turned in silence and in darkness, indifferent, unobserved. And then, on one small rock circling an ordinary star, a form of life appeared that eventually grew curious enough, and patient enough, and clever enough to reconstruct the whole thing from clues buried in stone and ice, to trace the rhythm of its own climate all the way out to 2 planets it could see only as points of light in the evening sky. We are incredibly small in this story. It is worth admitting that plainly, without flinching. We live inside the slow breath of planets that have no idea we're here, that would not notice if we vanished, that will go on shaping the Earth's orbit for billions of years after the last of us is gone. The giants are not aware of us. The ice is not aware of us. The rhythm was never keeping time for our benefit, and it will not stop keeping time when we are gone. Against the scale of the machine, a human life, a human civilization, the entire human story is a flicker, a thin sliver of one turn of a wheel that was spinning long before we arrived. But we figured out the rhythm anyway. That is the counterweight to all the smallness, and it is not a small thing at all. We pulled the beat out of simulations and ice cores and layered cliffs, and we understood for the first time in the history of life on this planet just how much of our warm, fragile, improbable story has always depended on giants we will never touch and never fully understand. We are the part of the solar system that learned to read the clock, and that, more than any fear, is what is worth carrying out of all this, into the quiet after the screen goes dark. Part 18. The wall of ice where your street is. Let me bring all of this back down to the ground beneath your feet, because it is easy to let a story this large float off into abstraction, and the truth of it is not abstract at all. Stand where you are standing and put yourself for a moment inside one of the cold ages we have been circling this whole time. Go back around 20,000 years to the last time the ice reached its worst, and imagine your own location, the exact spot where you are right now, as it would have been then. If you live anywhere across the northern half of the world, the ground under your feet is gone. In its place there is ice, not a distant glacier you would travel to see, not a white line on a far horizon, but a wall of frozen water standing directly over the land where your home is, taller than the tallest building in your city, a frozen ceiling pressing down on everything you know. In some places it is more than 3 kilometers thick, almost 2 miles of solid ice, and it is not still. It is grinding slowly southward, scraping the ground flat beneath it, dragging boulders and gouging the bedrock as it creeps. The air is bone dry and brutally cold, colder than any winter you have felt. The sea has pulled back so far that the beaches you know today sit far inland, the shoreline retreated over the horizon and out of sight. The forests are gone. In their place is frozen plain, running for hundreds of miles in every direction, empty and white and silent. And the thing that decided your patch of the planet would freeze was not a catastrophe, not an impact, not the sun going dim. It was the angle of the sunlight falling on the far north, set by a wobble and a stretch in the Earth's orbit, nudged by 2 planets you could not even see in the daytime sky. That is what it means to say the giants keep the rhythm. It is not an idea. It is not a diagram in a textbook or a curve on a graph. It is a wall of ice where your street is. When the geometry swings the wrong way, when the orbit and the tilt and the wobble conspire to starve the northern summers of sunlight, this is the world that grows, patiently, over thousands of years, until the place you are sitting right now lies buried beneath a frozen ceiling 2 miles thick. The pacemaker of the ice ages is not keeping time on some distant abstraction. It is keeping time on the ground beneath you, and it has done it before, to this exact ground, more than once. The land your city sits on has been buried and freed and buried again, over and over, across the long series of glaciations, each one paced by the same slow hands out in the dark. What feels to you like permanent, solid, obvious ground, the fixed floor of the world, is really just the current state of a surface that the rhythm has frozen and thawed dozens of times. You happen to be standing on it during a warm phase, during the open window, when the ice has retreated and the land is free. But the ground remembers the ice, and the giants that brought the ice are still out there, still pulling, still keeping the same time they have always kept. This is why the thumbnail idea of a reset is not really wrong, only slow. The word makes it sound sudden, a switch thrown, a world remade overnight. It is nothing like that. But over the long reach of geological time, the reset is real. The ice has swept this ground clean again and again, resetting the surface of the northern world, erasing forests and coastlines and rebuilding them, in a cycle that has been running for millions of years. We're simply living in the pause between 2 of its beats, in the warm gap, when the wall of ice has withdrawn and the land lies open. The reset is not a threat hanging over your life. It is the long rhythm of the place you live, and you happen to have been born into one of its calm intervals. To hold both of those truths at once, the wall of ice and the calm interval, is to feel the real shape of our situation. The ice is not coming for you, not on any time scale that touches your life or your children's lives or their children's. But it has come before, to this exact ground, and in the slow calendar of the giants it will come again, long after everyone reading the word tonight is gone. We live in the warm pause, aware for the first time in the history of life that the pause is a pause, that the ground beneath us is one frame in a rhythm far longer than ourselves, kept by 2 worlds we will never touch. And knowing that, strangely, does not have to frighten us. It can do something quieter. It can let us feel, fully and for the first time, the luck of the warm window we were handed. Part 19. The solar system is not a clock. We are taught, without ever quite being told it directly, that the solar system is a piece of clockwork. The image is everywhere, in the models that hang from classroom ceilings, in the neat diagrams of tidy circles nested one inside another, each planet gliding along its own fixed track as though the tracks were made of metal and the planets were beads strung on wire. It is a comforting picture, orderly and eternal, a machine that was wound up long ago and has been ticking along in perfect regularity ever since, each world minding its own orbit forever. And it is, in an important way, wrong. The real solar system is not a set of isolated tracks. It is a web of pulls. Every planet feels every other planet all the time, and those pulls are not fixed background details that can be safely ignored. They are constantly, gently, reshaping the orbits themselves. The path of the Earth is not a groove cut permanently into space. It is a compromise, worked out moment by moment between the enormous pull of the Sun and the smaller, shifting tugs of all the other worlds. And because those tugs shift, the compromise shifts too. The orbit drifts, it stretches and relaxes. It is a living thing, in a sense, responding continuously to everything around it. Not a bead on a wire, but a shape held in a slowly changing balance of forces. This is the truer meaning of everything we have talked about tonight. When Jupiter and Saturn bend the loop of Earth's orbit, they are not doing something exotic or unusual. They are simply doing, more powerfully than anyone else, what every planet is always doing to every other. The tidy ellipse you learned in school is an approximation, true enough for a single year or a single lifetime, but false over the long reach of geological time. Across tens of thousands of years, the approximation breaks down, and the real behavior of the orbit shows through, the slow breathing of its shape under the accumulated pull of the giants. The clockwork was always a simplification. Underneath it, the solar system is something looser and stranger and more alive, and at the far edges of that looseness, as we have seen, the orderliness can fail entirely. Push the mutual pulls far enough into the future, and the orbits stop being predictable at all. The small tugs that usually average out can, over billions of years, begin to feed on themselves, and the tidy machine reveals itself to have been standing near the edge of chaos the whole time. The same coupling that gives us the gentle, useful rhythm of the ice ages is the coupling that could, in the distant future, unmake an orbit. Order and chaos are not two different systems. They are the same system, seen at different lengths of time. The rhythm and the danger come from the same source, the endless mutual pulling of worlds that were never truly separate. There is something worth sitting with in that, because it changes how you see the sky. The planets are not strangers to one another, each alone in its own lane. They are bound together, every one of them, by threads of gravity that never break, into a single connected system in which nothing moves entirely on its own. When Jupiter shifts, we feel it. When Saturn leans, our orbit answers. The isolation we imagine, the sense that each planet is a separate island with its own private motion, is an illusion produced by the shortness of our own lives. We see the sky for a few decades and it looks fixed and separate. Given 100,000 years, it would look like what it is, a single restless machine of mutual pulls, every part of it quietly moving every other part. This is the machine that has been hiding in plain sight, out at the edge of the solar system, the whole time. It was never hidden because it was concealed. It was hidden because it was too slow and too large and too quiet for creatures like us to notice, running on a timescale so far beyond a human life that its motion looked like stillness. The bright dots in the evening sky, the ones we named and catalogued and then mostly forgot to think about, turned out to be the working parts of an engine that helps decide the climate of our own world. They were doing it all along, in full view, night after night, while nobody looked up and understood that anything was happening at all. And once you do understand it, the sky is never quite the same again. The next time you see Jupiter, that steady bright point that does not twinkle, you will know that you're looking at one of the two hands slowly bending the orbit of the world beneath your feet. The next time someone tells you the planets are far-off balls of gas with nothing to do with daily life on Earth, you will know better. The two biggest planets in the solar system have a measurable, ongoing grip on whether your part of the world is buried under ice or open to the sky. They have had it the entire time life has existed here. They have it right now. And the only thing that has changed in all the long history of that grip is that a small and curious species finally learned to look up and see the machine for what it is. Part 20. Watching the Clock. That is the part worth carrying with you tonight, after the screen goes dark and the room goes quiet. Not fear, not doom, not a wall of ice bearing down on anyone you love. Just the strange, quiet weight of knowing that the stable sky that let your ancestors stop running and start building was handed to you by the slow turning of orbits shaped by worlds you will never see. The warmth that made your entire world possible was an arrangement of gravity you had no vote in and no power over, and you were lucky enough, out of all the points on that long, slow wheel, to be born in the warm, open window before the ice comes back. Return one last time to the loop of wire and the two slow hands, because that image holds the whole story. Earth's orbit is the loop, thin and flexing. Jupiter and Saturn are the hands, one easing it more oval, the other easing it back toward round, neither rushing, neither tiring, neither ever letting go. Between them they keep the loop breathing in and out of shape, on a cycle 100,000 years long, and that breathing is the beat of the ice. The hands have been on the loop since before the Earth had oceans. They are on it right now, tonight, as you rest. And they will still be on it, still patiently bending, long after the last trace of us has faded from the surface of the world they are quietly shaping. We are tenants in a house whose foundations shift on a schedule we can barely perceive, and now, at last, we know it. That is the only thing that has really changed. The giants are doing exactly what they have always done, keeping exactly the time they have always kept. The orbit stretches and relaxes as it always has. The ice waits in the long calendar of the future as it always has. Nothing about the machine is different. The only new thing in the entire story is us, the tenants who finally looked up and worked out who was holding the thermostat, who traced the warmth of our own comfortable moment all the way out to 2 points of light in the evening sky. Think of what that means about our place in this. We're almost nothing against the scale of the machine. We live for a few decades inside a rhythm that takes 100,000 years to complete a single beat. We are one thin sliver of one turn of a wheel that was spinning long before our species existed and will keep spinning long after we're gone. The giants that keep our climate have no idea we're here and would not alter their motion by the smallest fraction if we vanished tonight. By every measure of size and time and power, we are small beyond describing, tenants who do not even own the ground we stand on, and yet we are the part of all of it that learned to read the clock. That is the thing that redeems the smallness, and it is not a small thing. The rhythm ran in silence and in darkness for millions of years, unwitnessed, the ice coming and going with no mind anywhere to mark a single beat. The only reason that time is not still passing in total silence, unread and unknown, is that one curious species on one small rock learned to read the clock written across the sky and buried in the ground beneath its feet. Jupiter and Saturn have been keeping time since long before we had a word for time, and tonight, just for a moment, we got to watch the clock. So let the giants keep their slow and patient rhythm out there in the dark, the way they always have and always will. Let the orbit breathe in and out of shape on its 100,000-year beat. Let the ice wait in the far reaches of the future, in the long calendar that has nothing to do with any night you will ever live through. None of it is coming for you. All of it is simply keeping time, the way it was keeping time before you were born and will keep time after you're gone, indifferent and enormous and slow. And you are here, in the warm window, in the open pause between the ice, lucky beyond reckoning to have been born into the calm stretch, and lucky in one more way besides. You are here in the brief moment when the tenants finally understood the house. You get to know whose slow hands have been shaping the sky above you the whole time. You get tonight to watch the clock, and then, gently, when you are ready, to close your eyes and let it keep its quiet time without you, the way it always has.